Hello everybody, my name is Craig Bennett and I'm the founder and owner of Tech Reviews Note. And today I'm talking about aerodynamics and fluid dynamics and orbital mechanics. Now, as far as things goes, I'm doing this unscripted to quicken up the time and whatnot. And as far as the aerodynamics and fluid dynamics, I'm not going to get too deep into this, mostly because as far as someone that actually dealt with orbital mechanics, I can tell you that aerodynamics and fluid dynamics doesn't play a huge part into the understanding of the overall orbital mechanics. However, there is some critical things that I need to point out before you make a mistake, either by not understanding aerodynamics or fluid dynamics, or by some other means. So let's jump on in. As far as things goes, taking a look at this plane, if you look at the underside side of it in a aerodynamics field, and sorry I don't have a chart showing this, but aerodynamic field, the wind under it is a high pressure, the wind over it is low pressure. This creates lift where the plane goes up. As far as other things, when the plane moves forward, that's thrust. Same thing when the rocket, basically when a rocket goes up, that's thrust. The anything that pushes the plane back, and the only difference between a plane and a rocket in this instance is the rocket's facing upwards to the sky. A plane is horizontal to the ground, so it's that's the only difference as far as these things I'm telling you right now. But anyways, anything that pushes back is drag, and there's a couple qualities of drag which I'm going to talk about in a second. Now, fluid dynamics is science of both gases and liquids, so that's something to keep in mind. There's not a lot of difference as far as the fluid dynamics of a gas and liquid, depending on what exact chemical you're talking about, but in the overall is very similar. For instance, with aerodynamics, again, high pressure on the bottom, low pressure at top, which creates lift. With fluid dynamics, with a liquid, you have high pressure on top, low pressure on bottom, which causes it to go down like a submarine or something. And instead of where aerodynamics, you got gravity pushing you down, if in a liquid you got buoyancy pushing you up. It's pretty simple. You don't need air for buoyancy. The gas just needs to be lighter than the liquid that you're in. It could even be melted metal for all I care, as long as it's a liquid and not a solid or gas. Now, as far as things like drag and whatnot, some very important things with drag is the thicker the atmosphere, the harder the drag is against the object. So liquids are obviously harder to move through. Most of us can contest through that. However, gas environments are very easy for us to move through. Again, the less stuff around you, the easier it is. Now, why is that? Well, when you're moving, it creates drag. You don't notice it during your day-to-day life, mostly because you're not moving that fast. Your body isn't, at least. Your car and whatnot definitely is. But as far as things goes, what happens is, with a gas environment or liquid environment, when you're pushing your body or a body through a particular area, it's pushing that gas or liquid up in that area, so it's making kind of like a wall. What's happening is, and I got no way to really show this that well, so I don't know if I should apologize for that or just simply say that, because I don't have a wind tunnel and I don't really have a way to show you this. But basically, when you having a plane or submarine go through air or water, what will happen is in front of the thing, since it is a mass going through a particular size area, if it's a box-shaped front, it'll create more of a drag because less of that air can get around it. However, if it's like a teardrop shape, it'll create less drag, but there still will be drag because at some point at a very tip or somewhere there will be a small amount of gas or liquid being pushed against the very tip. Then as far as when the gas or liquid moves around the outside of the object, being a plane or submarine, that creates drag around the gas or liquid that's not moving. So as far as that goes, why is it important to note drag? Well, obviously, slower you go, you won't even have an orbit. But as far as another important reason that a lot of people don't think about is heat. The more drag you have, the higher the heat, up to a point where you can have any metal, anything, and it will melt or burn. So that's very important to know how much drag you're going to experience, depending on what chemical you're going through or chemicals, and how are they affected on the drag. Just a calculation on how thick is the drag and how bad is it. This means that if the drag's high, you obviously don't want to fly a airplane out of cotton because it'll catch on fire during mid-flight. However, if the drag is pretty low, then go ahead. However, if the drag is high, you need to find something that won't melt or burn, depending on how high the drag is. Second, the other reason why the drag is very important is fuel. More drag, more fuel costs. That's pretty simple. It's just I guess they'll call it, for cars they'll be miles per gallon, but as far as that goes, is fuel. It's how much fuel costs going through a drag, which costs more. But as far as things goes, you have something called a slipstream, or it's also known as a draft. Basically, this just means that you can go behind something that already has drag, and if you're close enough where basically what will happen is when the air for this instance, comes off on the end, it will actually whip around and cause more of a drag effect over top. However, if you can extend it out, it'll cause less drag. It's why you'll see birds go in a V shape. It's why in racing sports, you'll see cars follow one another. And it's why bicycle sports, and not so much running, but bicycle sports, you'll see people following each other. They're just trying to go into a slipstream or a draft, whatever you want to call it. Same thing, it's just whatever you want to call it. I'm not going to get too deep into this because I need actual animations and whatnot, and I don't have the ability and knowledge to get you those animations. So as far as things goes, I think this is pretty much where I'm going to leave off. I'm thinking about making another series of videos talking about the difference between combat on ground and combat in space, which would be quite interesting because some of that would be very unknown-ish. So a lot of it would be theoretical, but because we never have war in space yet, and then keyword is yet. But yeah, whenever I get into that, I'm probably going to get into more of this if I get into that. But if you got any questions or whatnot, leave them below in the comment section, and I'll try to answer them as quickly as possible. Also, you can leave them the email on YouTube, or you can email me on techreviewsandhelp.com. If you found this video helpful at all, then please like, please share, and please have a great day.